Welcome friends, a big hello from Yotasys. Today we will be demonstrating one of our most innovative offerings, Yota Site Search Analytics. Yota Site Search Analytics is an e-commerce site search analysis and optimization solution. We will take a quick tour about the background for Yotasys and then go straight into the Yota Site Search Analytics solution. Here is the flow of this discussion. Let's start with the Yotasys definition of analytics. Our definition of analytics is simple: anything which helps our customers take intelligent decisions based on comprehensive data discovery. Our analytical solutions are based on one data foundation and include structured, unstructured, and machine data sets. Yotasys believes strongly in the application of a combination of statistical, business, and deep technical expertise. Our key differentiator lies in our heavy usage of ready-to-deploy solutions across the key sectors of retail, energy, and financial services. These solutions can be considered as products at the alpha stage of development and can be implemented with a minimal customization. We are a 5-month-old company and we already have 5 key solutions cutting across the key sectors of retail, energy, and financial services. The solution in focus today is Yota Site Search Optimization Solution. Yota Site Search Optimization is a framework for analyzing and optimizing e-commerce site search platforms and can be implemented in 4 simple steps. Let's go through all the 4 steps in detail. The first step in this direction is identifying the key improvement areas. We can start with asking simple questions. How accurate and relevant are the search engine results? How does the search engine filter and sort the return data set? Is there a provision for handling queries which return 0 results? In our step number 3, we will do a deep dive into the Yotasys analytical platform which automates the discovery phase. Once we have identified our improvement areas, the next step consists of confirming this discovery by matching it with the relevant data sets. Yotasys has automated this process by our in-house analytical tool. We simply need the Site Catalyst, Solar, and Endica log files to fetch out our analysis. Let's take a deep dive into the Yotasys analytical engine. Let's start the demo by logging into the system. The first dashboard page focuses on various kinds of segmentations. This chart number 1, which you see now, provides the total customer visits by geography. If we hover over the pie, we can see the numbers in the slice. For example, for the state of California, the second horizontal bar chart, which we see now, provides the number of visits by product category. For example, in this data set, the total number of customers who chose the clothing category product was the highest. Finally, chart number 3 in this dashboard provides the total number of visits by IP addresses. It is possible to convert these IP addresses to the URLs of their origin. The last chart number 4, provides us the total number of visits by website pages. For example, we can see from the chart that line item number 3, gaming, and line item number 4, electronics, are the pages which are driving around 5% of the website traffic. Let's move to the next tab, which is the focus tab. The first chart number 5, which we see now, provides us insight into the age groups our products are most popular. For example, the age group 27 is driving the second largest traffic into our e-commerce platform. Chart number 6 provides us further details on the geographic distribution. For example, we can clearly see that San Diego, New York and Madison are three top cities which are driving the maximum website traffic. Finally, chart number 7, category by time, shows a product category and its incline or decline over a complete period of time. Let's move to the next tab, Assess tab. Chart number 8 provides the time taken by queries based on specific range buckets. For example, from chart number 8, we know that maximum queries are taking less than a second. The results are being provided from the search cache. Chart number 9 provides us a list of inefficient queries. For example, there are 7 queries which are taking more than 30 seconds. Not an optimum performance for any e-commerce transaction platform. These are the prospective queries for further fine-tuning. As we continue our demo, we will further evaluate these queries in detail. Chart number 10 provides us further details on the type of queries being issued to the search engine. As we can see, there are around 29% of the total queries which are being issued as suggest queries, while 22% of the queries as select queries. Finally, chart number 11 provides the count of queries with a status. Any query with a status other than 0 is actually a search with no data returned. In the given chart, we see that 52 queries out of the total count of 1600 queries are not returning any results. This can be a very high number in a real-time e-commerce system, and this analysis creates a key section for optimization exercise. The next dashboard which we see now is the Ad dashboard. In this dashboard, we will identify key elements for the optimization exercise. Chart number 12 gives us a complete pattern in the week about the nulls returned in our e-commerce platform. As we can see, there are continuous peaks of nulls returned in the dataset across the board. In our next step, which is optimization of e-commerce platform, we'll focus on creation of query libraries which can serve as substitutes for any null search results. Udasys optimization framework operates in 7 phases. Out of these 7 phases, we have already completed 4 phases. Finally, in step number 4, we do the data modeling phase, the A/B split testing phase, and finally, when the results look good, we implement that into our QA and production environment. For the purposes of demonstration, one of the sample algorithms for query substitution for null results is also being shown in the respective flowchart. Let me summarize what we did so far. We started with identification of our site search improvement areas. We extracted information from 3 log files. We analyzed the results using Udasys automated analytical tool, and finally we implemented